Hello, this is page 2 of derivatives differentiation. On this page, we're going to learn how the calculator can help us do calculus. Okay. First of all, on page 1, we did a lot of work that did not use the calculator. And as a result, we always got these functions. We always got these functions that have x in it, right? These are useful tools because later we can put it in whatever x value we want, and then we can get the slope at any point on the curve. However, if you know exactly what point you want the slope or gradient at, like let's say maybe you already know that you want the slope at x equals 3, the calculator can do everything for you. Okay, so let's try one of those. Like for example, we have some very complicated looking functions here. Some of these we don't even know how to take the derivative of. We can use the calculator to find the derivative, but at a specific point like x equals 3. So let's try it out. As usual, when they give you a function, first thing you do is type it in the calculator in the y1. So let's type this in, okay? Let's type this in as a vertical fraction so we don't need to worry about the parentheses. So we press math, number, go to the bottom by pressing up, and then we type in x squared, and then on the bottom we put x minus 1. It's in there, okay? And we could graph it. Oh, I forgot to take out the stuff from page 1. Let's change stat plot so that it's off. And then we graph. Okay, let's do zoom fit. Zoom fit. I think it's 0, option 0. Okay, pretty weird function. Okay, we want to find the slope of this curve at x equals 3, probably around there. Let's do it. The way you do it is you do second calc, our old friend second calc. We've used most of these options. We've used option 0, we've used minimum, we've used maximum, we've used intersect. We're going to use dy dx, which is the derivative. And then we type in the number 3. There you go. It says that the dy dx, the derivative value, is 0.749999999. If we round this, it'll be 0.75. Okay? So our answer would be y dash equals 0.75. Okay? Let's do the next one. Y equals x natural log of x. Again, all you have to do is know how to type it into the calculator. X natural log x. Graph. Okay, and we want to know what the derivative is, what the slope is at about this point here. How do we do that? We're going to go second calc 6 dy dx, and we'll type in the value 3. And it says the value is 2.0986. If we want 3 sig figs, 2.09 would round up to 2.10. Okay, next one. Again, the only challenge in this is how to type these complex functions in the calculator. Again, let's go ahead and use the vertical fraction so we don't need to worry about putting parentheses on the top and the bottom. Number. Okay. 2x squared minus 1. On the bottom, x plus 3. Graph. And we're going to find the derivative at x equals 3. So let's do that. We'll do second calc. Derivative is number 6. And then we type in 3, enter. And the answer is 1.53. Y dash equals 1.53. Okay, next one. S equals t plus 5 divided by t cubed plus 1. Again, we're going to want to use math number and n/d. And we're going to put x plus 5 on top because there's no t. We need to replace any variables that are not x with just x. X cubed, right arrow, plus 1, graph. Okay, and now we're just going to check the derivative at x equals 3, which is around there. Second, calc, number 6, type 3, enter. And the answer is negative 0.2397. The 7 is going to round the 9 up to a 0, so it would be negative 2.40 if we want 3 significant figs. Negative 0.240. Okay, next one. X e to the 2x. X e, that e is here, second natural log is e, 2x. Graph. It's off the screen. I don't know if I'll be able to do it if I don't adjust the zoom. Let's see if it works. Second calc, 6, which is derivative, 3, enter. It does it anyway. The derivative is 2824. 2824. That is huge. What a huge slope. Okay. Last one. And this is a great, remember how to take the derivative of this on page 1 we needed to expand it? Well, calculator doesn't care. Calculator does not need to expand it. We just type it in as is. You're saying, why don't we just use this for all of calculus? Well, if you remember, sometimes they want to find the derivative in general. They want to leave the x still in the equation. So if that's the case, we need to do it by hand. Because the derivatives we're taking right now are only like at a certain point, x equals 3. X squared minus 3, parentheses, x minus 1, quantity to the 5th. Okay, so we're going to do a graph. And then we're going to do second calc. Second calc. Intersect, no. Derivative, 6. 3, enter. 672. Okay? Isn't that easy? Super easy. Okay, so if they ever ask you for the derivative at a certain point, and how do they do that? They'll say find the gradient. Gradient, remember, is slope or derivative, where x equals 3. So if they ask you for the derivative at a certain point, then we can use the calculator, second calc dy dx function. All right. Let's look at a few more problems where the calculator can help. So, point P lies on this curve. Okay, what do we do when we get a curve? We immediately type it into the calculator, right? So let's type it in the calculator. Y equals x squared plus 3x minus 4. And when I graph this, I'm just going to do a regular zoom. I'm going to do zoom standard, which is 6, because I think we'll have, yeah, it's pretty much, in the right place here. Okay, so here is our function. I just wanted to draw this function so that we could talk about what this means. The gradient of the curve at P is, the point P lies on the curve. The gradient of the curve at P is equal to 7. Find the gradient function of the curve, find the x coordinate of P, find the y coordinate of P. So let's talk about what this means first. So we have this very nice blue parabola, okay? They're saying that there is a point somewhere on the parabola, they don't say where, that the slope is about 7. What slope would be 7? It would look kind of like this. It would be like 1 across and 7 tall, so it's a very tall slope. That would probably be around here somewhere, right? Maybe point P is around here, okay? How do we find point P? Well, first of all, we need to do what we did on page 1. We're going to find the derivative of this function here. Remember the power rule. So we're going to do y dash equals, and the derivative of x squared is 2x to the first, right? The derivative of 3x is 3, and the derivative of negative 4 is 0, so we just write y dash equals 2x plus 3. We found the derivative function, okay? Now, how do we find the coordinates of this point here, knowing that we want this very steep slope of 7? Okay, so now this is a procedure that I'd like you to use throughout this packet. So x squared plus 3x minus 4, we did instinctively, we put the original function into y1. Next thing we're going to do is we're going to put the derivative function, which I like that it's red because it reminds me of the investigation when the numbers were red. I put the derivative function into y2. Then I look at the table, and I can see all sorts of numbers here. And now what I'm looking for is I'm looking for when the function has a slope of 7. In other words, I want the red 7 because the derivative function is red. Oh, it's right there. So the red 7 is here, which means the slope of 7 is here. What is the x value at that point? It's 2. Okay, so x equals 2. What is the y value at that point P? So that would be 6. So there's 3 numbers that we need to think about here. The x coordinate, the y coordinate, and the slope. In this, let's go back to the graph again. In this graph, let me turn this off because the derivative function is kind of distracting and doesn't really have any meaning. So not in this context. So okay, so here is the parabola. At what point is the derivative 7? And we found out that it's at 2, 6. So it's about there. Okay. How did we find out? We looked at the table. The table's the easiest way to see that. Okay. Let's do a couple more. Okay. You'll see that maybe you don't understand completely, but the routine is pretty simple. Number 5. Find the coordinates of the point on the curve where the curve y equals 3x squared plus x minus 5, at which the gradient of the curve is 4. So it's pretty much asking the same thing. In this particular case, they give us a function, which is 3x squared plus x minus 5. The original function always goes in y1. And then what goes into y2? The derivative function. Now, in this case, they didn't ask us to specifically take the derivative like they did last time, but we know that we need to do that because that's how we find when the gradient is 4. So how do we do the derivative again? So we leave 3 where it is because it's a coefficient. We bring down the exponent, and then we bring down the base of x, and then we reduce 2 by 1, and so it's just an exponent of 1. And then the next one we have plus 1x. The derivative of 1x is just 1. The derivative of negative 5 is 0. So we're almost done here. The derivative is y dash equals 3 times 2, x plus 1. Let's simplify that, 6x plus 1. Okay? So we're going to put 6x plus 1 in y2 because that's the derivative function. And we're always going to put the derivative function in the red part. Those of you who have black and white calculators, this is one case where the color calculator I think really helps. Let's go to second table. And let's find where we have a red 4 because the derivative they want is 4. I don't see any red 4s. What do we do when we don't see a red 4? But we know it's somewhere between these two here. Okay, what we can do is we could use plus 0.1, right? we do plus 0.1, maybe we'll find it. Oh, there it is. It's right there. So the red 4 is here. The x-coordinate at red 4 is 0.5. Do we want the y-coordinate too? Yeah, because they said the coordinates of the point. So they want the y-coordinate too. The y-coordinate happens to be negative 3.75. Okay, great. Number 9. There are 2 points on the curve, and this is a pretty, this has a cubed in and everything. Let's type this one into the calculator. There's 2 points that have a gradient of 0. So it says find both points. Okay. X cubed. I do circumflex the base, and then press the right arrow. 12x plus 5. And then I'm going to do second table. Okay, I want to get the derivative function now so that I have the red numbers because I want to find when the red number is 0. So what is the derivative of x cubed minus 12x plus 5? The derivative of x cubed is 3x squared. The derivative of negative 12x is negative 12. So there's my derivative function. I'm going to put that into y2. Put that here. It's going to be 3x squared. Oops, not that. 3x squared minus 12. Table. And I'm looking for when there's a red 0. Oops, I forgot to make it go back to normal. Let me do second table set. And I'm going to change table start to 0. And now I'm going to go back to, oops, I need to change delta table to 1. 0, 1 as the standard setting. Second table. Okay. Oh, I see 1, 0. One of the zeros is here. So this 0 occurs at 2, negative 11. Right? Black 2, blue negative 11. The black is the x. The blue is the y coordinate. The y coordinate. And remember the red is the slope. Okay? All right. And the other point that has a curve of, or that has a gradient of 0, let's find that. Oh, there we go. I just went up a little bit and there it is. Negative 2, 21. So these are the two coordinates pairs that have a red 0. Okay, what does that mean when you have a gradient of 0? It means that the gradient is flat. I'm just going to graph this for a second. Maybe we can see where the gradient is flat. Well, I'm going to have to like zoom fit a little bit maybe. Oh, let me turn off the derivative function because it's not helpful. Turn this off. And now I'm going to graph. Okay. Now I'm going to adjust the zoom to zoom fit, which is 0. Okay. Okay. So the two places that you're going to see a gradient of 0 is when this thing flattens out. So it flattens out there, right? Then it goes down a little bit, and then it flattens out here again. So one of the points would be around here, and one of the points would be around here. So one of them is negative 2, 21. That's here. And the other one's going to be around 2, negative 11. That's here. Okay, so that you can kind of imagine what the 2 points are which have slopes of zeros. Okay, that's it.